This is an introduction to the Desert Buckeyes team and the Ion vehicle they are preparing for the 2005 DARPA Grand Challenge. The Desert Buckeyes are located in Columbus, Ohio, and receive their primary support from The Ohio State University. The DARPA Grand Challenge is a race and field test of fully autonomous ground vehicles covering an off-road course of up to 175 miles in the desert Southwest. Most members of the Desert Buckeyes participated in the 2004 DARPA Grand Challenge as Team Terramax. Terramax was a large Oshkosh military truck which the Ohio State University group transformed into an autonomous vehicle by outfitting the truck with sensors, designing the drive-by-wire actuation, and most importantly developing the algorithms and software for intelligent behavior. Terramax was one of a handful of vehicles to successfully complete the qualification course at the California Speedway. And this year, we will have greater intelligence with more sensing capabilities and a more robust computer architecture on a faster, more agile vehicle platform. Introducing Ion, the intelligent off-road navigator. Ion is based on a 2005 Polaris Ranger, a gasoline-powered off-road utility vehicle, with on-demand six-wheel drive, independent front and center wheel suspension, and swing-arm rear suspension. The vehicle measures 10 feet long by 5 feet wide, has a turning radius of 15 feet, can ford up to 27 inches of water, and has a top speed of 41 miles per hour. The Ion vehicle has already been equipped with a number of key components. Looking at the front of the vehicle, we see a scanning laser rangefinder and a commercial long-range radar system mounted behind a protective bumper. A scanning radar system being developed by the Ohio State University Electroscience Lab will be mounted in approximately the position shown. A stereo imaging system and possibly an infrared camera will be mounted on the top bar. Additional laser rangefinders can be mounted at various heights along the vehicle. In addition, short-range ultrasonic sensors can be mounted around the vehicle's perimeter. Looking under the hood of the vehicle, we can see the steering actuator and controller connected to the steering gear and the throttle actuator. We also see a prototype installation of the low-level interface electronics, as well as a brake pressure sensor. Actuators for braking and transmission are not shown. Examining the rear of the vehicle, we see the antenna for the GPS receiver. Not visible is a magnetic compass. A generator and a foam-filled racing fuel cell are also visible. You can also see the temporary e-stop receiver mounted to the front of the vehicle. Finally, we see a fan-cooled computer and electronics chassis. Looking inside the electronics cabinet, we see the control and sensor processing computers. Not yet mounted is the image processing computer system. Not visible from this angle is the GPS receiver, an inertial navigation unit, and several power supplies and other interfacing electronics. A number of technologies will contribute to the success of Ion. The mapping support for Ion includes automatic and dynamic path planning algorithms, as well as tools for interactive path planning and adjustment immediately prior to the race, using elevation data, imagery, land cover, and road databases. High-level control and sensor fusion algorithms are being refined, tested in simulation, and implemented on several different platforms. Tools for post-run analysis are helping to understand and tune Ion's behavior. A new innovation this year is a scanning radar system to investigate obstacle characteristics. The radar system and ultrasonic array system are being developed by the Ohio State University Electroscience Laboratory. Also this year, we have partnered with a group from the University of Karlsruhe, Germany, who are developing a stereo imaging system for Ion that will identify free space, paths, and obstacles ahead of the vehicle using 3D scene reconstruction and image texture information. Ion, still under development by the Desert Buckeye team, is a fully drive-by-wire vehicle. In this demonstration of fully autonomous waypoint following, the vehicle accelerates smoothly to 5 meters per second, or approximately 12 miles per hour, follows a complicated course through a field near the Ohio State University campus, and then comes to a stop at the end of the test course, all without human intervention. As we continue to add sensors and sensor fusion functionality, and to reintegrate and expand on our existing multi-level control algorithms, we expect to produce an exciting and capable vehicle that will be a solid competitor in this year's DARPA Grand Challenge.